right. Well, welcome everyone. I think this has been called a few different things. But if you're looking for guidance on some cool climate tools, climate data tools, you're in the right spot. I'm Sherry Bell. I'm with Climate Central. I'm also the moderator today. That just happened a couple hours ago. So welcome. With me is my colleague, Andy Pershing from Climate Central. And Melissa, and already I've got it wrong, Woodhill. Got it. Close enough. Who's with the Midwest Regional Climate Center. We're go ahead and kick it off.
Sherry, we're going to do the who are they?
Oh, I'm sorry. Yes, duh. One of the first things about communication is like know your audience, right? So we just kind of wanted to get a sense of who is here. So who is with sort of an academic institution? Okay. NGO? Yeah. Business? Okay, one. What am I missing here?
State government.
A government, yeah.
Community organization.
Yeah. Okay, anything else? No? All right, good to know. Thanks, Andy.
All right, I'm going to do this. Can everyone hear me okay? Excellent. So I'm Melissa Widhelm. I am the Associate Director and Regional Climatologist at the Midwestern Regional Climate Center. There are 6 regional climate centers in the U.S. Can I see a show of hands of who's heard of a regional climate center before? Okay, there's a few hands. That's good. So I hopefully won't bore you to death then with my presentation. I will say that really my goal is to just orient you on the landscape of some of the most common places you can go for freely available historical climate observation data. Okay, there are a lot of words in there. So I'm talking about observational data, not really modeled or computer simulated data. We're talking a lot more about our historical observations, and so actual measurements on the ground, and things that are freely available. There are a lot of different observational networks out there and places that you can go for information beyond what I'm going to tell you about today. I'm mostly going to focus, I guess I could advance the slide and you'll see what I'll focus on. I'll give you an example at the federal level, some examples from the regional scale, because again, I'm from the Midwestern Regional Climate Center. We provide tools and information to help people access and make use of historical climate data. And then I think there's some state level resources that you may or may not be familiar with, but that I feel very strongly would be helpful in climate adaptation, climate advocacy, climate mitigation, climate impact work, the variety of work that folks attending this actual conference can make use of. So that's why I wanted to touch on some state level resources as well. And so we can really think about this as weather and climate data for non-meteorologists. Do I have any meteorologists in the room besides myself? Got one, okay. It still will be helpful for you, I promise. Okay, good. That was the audience I was going for, was weather and climate data for non-meteorologists. And maybe one meteorologist. So you'll see this again when I talk about, it's a little bit small. You'll see this again when I get to my section on regional climate centers, but just to orient you a little bit on who I am, again, Midwestern Regional Climate Center. You can see in our logo the states that we cover. It's most of the states covered by the Midwest Climate Collaborative, excluding the High Plains states from the Dakotas down to Nebraska, including Michigan, including Kentucky. So one thing you'll find is that with a lot of climate-related organizations, whether they focus on observational data or maybe they do more work like the CASCs. I don't know if anybody's familiar with a CASC, a Climate Adaptation and Science Center, or a climate hub from the U.S. Department of Agriculture, right? There's all these different layers of folks who provide climate data, climate services, and they don't exactly overlap in their geographic interests. So it's just the nature of things. And even with the Midwest Climate Collaborative, right, you have your own geographic area of interest. I'm sure the boundaries are a bit fuzzy. The good news about the Regional Climate Center is while we're regional in scope, a lot of our data that we provide is for the whole nation. You can find a lot of information for outside of this particular region. So even though I'm talking about regional, it goes beyond that. So at the Midwestern Regional Climate Center that I direct, these are sort of the things we do, right? We have tools to help you make decisions. And that could be on a variety of different levels. I'll show you some examples where it's very much just, I'm going to look at the data so I know what happened last week. Or I'm going to look at how last month compared to historical. That's part of what we do. But we also provide derived information, summaries of information, add that value. We have customized data services. So I have people who are in a car accident and they're fighting with their insurance company and they need me to certify that their record is what it says it is. That's very different than doing research and education and outreach on regionally relevant information issues, which we also do. So we span a lot of different things, but one of the most important and my favorite things that we do down here is engaging stakeholders to identify information needs. And so I think that's also a lot of what our folks at Climate Central do. And so we will spend some time towards the end of today's session asking you what you need. Right? We're telling you about things that are available. It's not everything that's available, and it's not the only thing that people need. And so I want to leave this as an open invitation to, at any time now or however long into the future, if there is something you need, let us know. Because part of my job is to run it up the chain at the National Oceanic and Atmospheric Administration, NOAA, right? I'm in academia. We use lots and lots of acronyms. We will rival that of the federal government. We like acronyms just as much as they do, and I will try my best not to overwhelm you with them, but I make no promises. So we run up the chain at NOAA, the National Oceanic and Atmospheric Administration, and tell them, this is what people on the ground are saying they need to make use out of the data you're collecting. This is how people want to use the data, the format they need it in, the types of decisions they're making, so that we can make it a funding priority and make it a reality. Okay? So anyway, that's enough about me. If I start to go too long,
Yeah, go ahead.
give me the hook. Okay. So like I said, I wanted to first start with our federal level. So I'm just going to run through a couple of things just to kind of get you thinking about where does this climate data that everybody talks about actually come from. So has anybody ever heard of a co-op observer, the National Weather Service Cooperative Observer Program? I saw one faint hand. Okay, so this is one of the most popular and long-running climate data networks that we have in the U.S. You can see lots of different locations that are represented. These are daily measurements of temperature, so how high and low did it get for a day, and precipitation, how much snow did we have, how much liquid fell. This is our most popular, longest running, most robust data that we have observationally. In some cases, these data might go back to the 1800s. However, you can see when we zoom in, this is Indiana. Here's where I live, that's why I picked this. You can see we have a smattering of stations that are currently collecting information, that have stopped collecting information. You have lots of different time scales, okay? But we're only getting temperature and precipitation, more or less. Well, a lot of people want to know about heat index. A lot of people want to know about wind chill. A lot of people want to know about these other variables that you can't just get on your own with just temperature and precipitation. Okay, so as much as this data set is useful and it can help us understand long-term trends and changes in the most popular climate-related variables, it's not the only thing that we have. So there's also, from the federal government, the FAA, Federal Aviation Administration, runs a set of weather stations that collect what we call hourly data. All right, so the last one was daily data. Once per day, you get a measurement. That's an average over that day, or an extreme over that day. Now we have hourly weather measurements. As you can imagine, we don't have those going back to the 1800s. So really from about 1948 onward is when we have a lot of these measurements. They're located at airports. They might also be a co-op, that previous section. They might also collect that data. But what's interesting is they have a lot more sensors. We get hourly, on the hour, temperature, precipitation, humidity, wind speed, wind direction, pressure of the air, the cloud height, all of these things that you kind of need for, taking off and landing in an aircraft. And that's their primary goal, right? We want to make sure aviation is safe, but climate and weather scientists and practitioners in the field who need weather data find this useful as well. Then we have the Climate Reference Network. So the Climate Reference Network is an automated set of stations. So I should say that co-op observations, those are people manually going out and reading a sensor and entering it in, okay? Now we're getting into more technology, more automation, and we can get these hourly Climate Reference Network stations. These are really high caliber measurement equipment. We have it hourly, but again, we have some variables that temperature, precipitation, pretty standard, but we don't get wind, we don't get pressure, we don't get clouds, but we do get soil parameters. So if you're somebody working in agriculture, ecology, many, flood protection, gosh, the soils are actually quite important for a lot of these processes. It is a measurement we don't have a lot of, okay? So now we get soil temperature, soil moisture, solar radiation, again, right? How much light is coming in, hitting the ground from the sun, how much radiation is emitted off the earth, going out into space, or getting trapped in our atmosphere and warming our world, right? These are the types of observations we have. But take note, these are only around since the late 1990s. So you're sitting here thinking, but I have all of these other climate information needs that I have. Well, there's maybe not direct observations, but we do have a really good understanding of atmospheric physics. And we do have an entire subset of the profession of climatology and meteorology that works on developing representations of our atmosphere in the computer, so a computer model or simulation, that can then start to backfill some of these missing pieces of information. So when we see things on Twitter, when somebody says, oh, look it, we've done an analysis to show that January was the second cloudiest on record going back to the late 70s here in the Midwest, we know that because we've used computer simulations to do that. We don't have actual observations. We do a lot of this work using a mixture of both computer simulations and historical observation or observational data sets. And that's really important to know, because if we want to get information about some of these things, cloud cover, storm patterns, heavy rainfall patterns that are less than just a one-day total, we need to be using other types of tools. And there is an entire science dedicated to helping us do that. So I'm not going to talk anymore about these computer simulations. I just want to put it out there that these things exist, and they're based on what we know from our observational record. So where do you find all of this data? Well, this is a picture of my website, Midwestern Regional Climate Center, and we have a tool called Climate, the MRCC Application Tools Environment. It's a self-service data portal. That's one place to get it, and I'll come back to this because it's quite important. But a lot of times people don't necessarily want to get all of that raw data and crunch all of those numbers. You're like, whoa, that's beyond what I need to tell the story of what's happening in my local climate. Maybe I need something a little more streamlined. And so one tool that I want to introduce you to is Climate at a Glance. Has anybody ever heard of Climate at a Glance? It's phenomenal. I love it. It's not always available. They do have some network things. You'll get a red bar across the top. Climate at a Glance is not available today. So just know that they are working on stabilizing that system, but it is so powerful. I won't walk you through every step, but just to point out a few things, across the top here, you can see that through Climate at a Glance, which is managed by NOAA, the National Oceanic and Atmospheric Administration, and their subgroup is the National Centers for Environmental Information, NCEI. You'll see that up in the corner to know that that's what I'm talking about in these next few slides. NCEI's Climate at a Glance gives you the ability to take all of these daily, weekly, monthly observations and synthesize them to different scales. global, national, regional, statewide, divisional, county, city. Okay, so it is a way to get this more polished, pre-packaged information. You look at the row below it, I can look at maps, I can look at time series, we'll get to that in a moment. Rankings, how does this particular weather event compare to a historical climate normal, or normal, right? As scientists, we say normal, and we're really talking about an average over the most recent 30-year period. So if you hear me say a climate normal, these are these averages from 1990 to 2020, 1991 to 2020. Haywood plots, I won't talk about that, but that's a way to track and rank our season, month to month, how it compares to other years. So anyway, data mapping, say you were to go to divisional, so we can break down our geographic areas. We can go from the state level down to a smaller clustering of counties that climatologists call climate divisions. So if you see that word, climate division, each state has, anywhere from 4 to 9 climate divisions. It's just a clustering of counties in a geographic area. And you'll see it on the map here in a minute. So I can go to divisional, I can go to mapping, I can select, do I want this to be averaged together for the entire US? Do I want it for my entire state? Do I want it for a sub-region of my state? You have a lot of control and customization over this. Do I want to look at temperature or hit this caret here and see, I can look at max temperature, min temperature, rainfall, all these different parameters. And then I can pick my time period. Do I want just to look at February? Or do I want to see every February going back in time? Do I want to see a clustering of months? You'll just have to play around with it to see all the things they have to offer. But then it generates this beautiful map like this. And if we just kind of digest it for a moment together, this is showing in January the climate divisions. That's these little odd-shaped clustering of counties within a state. And it tells you an anomaly, if that's what you want, like how much is it above or below what we expected. It can just tell you the value, right? So here we see the scale. And on average, where I lived, it was ranging from 20 to 30 degrees. Well, I can click on the anomaly and is that higher or lower than what I should expect? Why would we know this off the top of our head? We have to look at the data, and it can be adjusted to tell us that. So you can get rankings, you can scroll down, see a whole listing. It tells you things like, it was the 63rd warmest in the US, things like that. So if that's what you need when you're writing your newsletters, when you're publicizing to your communities, when you're trying to make a point about a current month being extreme or a current season being extreme, this tool can be extremely helpful for you. The time series works the same way. You have all sorts of options to pick. And that's how you end up with a chart that you can look at over time to show across the bottom. Here's our time, right? It's a time series. And so each of these dots is representing a time period. And then going up and down the axis is showing the variable moving. And you can apply a trend and you can say, well, gosh, in Indiana, our Februaries are starting to get warmer. They're actually 0.3 degrees per decade is what the trend is in the warming, right? And we can see that clearly in this data. We can see what our average is. We can see how each individual point compares to the average, and then we can figure out the trend. It does all of that for us. We don't have to have all of the data downloaded and crunching the numbers ourselves. And that's why this system is so powerful. They have so many other tools at the National Centers for Environmental Information. I encourage you to go to their site, and I caution you, you will be overwhelmed with the amount of information. But some key things to look for, they have monthly summarized climate reports, and so they have an expert go through and sort of pull out the high points. They have the $1 billion weather disasters database. And so if you'll remember, do we have anybody from Kentucky or the lower Midwest? No? Okay, so December 2021, we had some massive tornado outbreak. We had one of the longest lived tornadoes in the state of Kentucky on record for December. We had, I don't know how much in damages. It made the $1 billion disaster report. So a couple of months later, you were able to go in and see on the map a big tornado symbol, and there it was. So if you're wondering, was this event widespread? Did it cause a lot of damage? Any kind of event in the US that exceeds $1 billion in losses will be reported on that map. So they have national trends. You can get different temperature and precipitation products. All of this is very credible, freely available, and open to you to use as you see fit. All right, so moving right along in the interest of time, let me talk about some of the products and tools available from regional centers. So like I said in the beginning, I'm from the Midwestern Regional Climate Center. There's also a High Plains, Southern region, Southeast. You can see them all here on the map. We all do more or less the same mission, but how we execute that mission is a little bit different. So again, we write reports, we monitor the conditions, we try to help connect people with the informational data sets that they're looking for. We work on customized projects. If you're doing a research project or an engagement project and you need access to some of this information that I'm sharing with you, but you're just like, I lost my notes, you went too fast, I don't know where to find it, reach out. That is literally our job, is to help make climate information accessible to you. And so the big thing here is we do focus on regionally relevant needs in the Midwest. Our regional focus is on agriculture and water resources, but that's not the only thing we do. So if you go to our website, which again is mrcc.purdue.edu, you will see our homepage, some hot links to a lot of our tools and products. I have literally too many products to even think about showing today, and so I will pass around this form, which is our product overview, and I'll have a slide for this in a little bit. It highlights some of the most popular tools just to give you a flavoring of what you could be looking for when you come to our site. I also have a handout here on our Climate self-service data portal, which I'll talk about in a minute. I'm only going to give you a couple of examples of what you can do with Climate. This form actually tells you a whole lot more. So those are two useful resources. So Climate, going back to what you see here on the screen, when you go to our homepage, our two most popular items, Climate, which is our self-service data portal, and Midwest Climate Watch. So Midwest Climate Watch has ready-to-view maps of just common variables to help you monitor current conditions and put those conditions into a historical perspective. So if you're like, gosh, how cold did it get here a couple of days ago? You can go to our daily station map. You'll see everything's kind of nested in. We have daily stations, we have hourly. Remember, different types of variables are measured at different temporal frequencies. Is it daily, is it hourly? That's why we have those sectioned off in that way. So anyway, if you wanted to go in, and note of caution on my slides here, these are not the most current condition. These are from when I built the presentation. You click on it, you get a pop-up, and you can just quickly mouse across and the map will change, right? So this is really, I'm not looking for decision support. I'm not looking for intense historical data analysis. I just really need a summarized snapshot of what happened with as few clicks as possible. Then Midwest Climate Watch is the tool for you. Maybe you want to look at not just what happened in a day, but how about this week? How about how it compares year to date, month to date, the last 30 days? Perhaps you're interested in temperature or maybe precipitation. It all works the same. You click on the button and the map pops up for that time period. We do have Midwest Climate Watch for specialized topics. So if you click on that special topics button, you'll see similar information to what you see on the main page for things like agriculture or drought or Great Lakes or temperature inversions or winter. So we've tried to categorize it almost like a clearinghouse of where you can find sort of this snapshot, real-time weather and climate information. Now, Climate, which I've been talking about, this is a little bit more powerful. And you can kind of think of it like the NCEI, the National Centers for Environmental Information's Climate at a Glance that we started with, only it kind of drills you in more to that raw data, and it gives you a whole lot more customization power. How it works is really along the top, you select your station of interest, right? These are station-based products, most of them. And along the left-hand side, that's where you kind of navigate to all the individual tools. In the middle, we have hot links to some of our most popular, most used tools. So if you're like, I don't have any idea what you're talking about, Melissa, what do you mean tools? What kind of data are we talking about? Let me just walk you through an example. So here we're going to look at monthly rankings. So if I navigate to the monthly rankings tool, I can see that I can specify my time period. So in this case, this is looking at April, only April's, for the whole period of record for the station that I picked, which I'm pretty sure is West Lafayette. I can say I just want to look at precipitation and give me a chart, and there you go. It actually generates a table, and you can literally look at each year and how much rainfall you got in that month, right? You can sort it in different ways, and you can look, oh, gee, the 2013 April had the most rainfall for my location. So for some applications, you might really need that monthly time scale. Maybe you need to know it for a specific week or a year or a season. All of those variations are options in the tool. You're like, okay, well, that's not, I don't live in averages. I don't really, that monthly time scale isn't what I most need. Let's look at a threshold search. Let's look at, for the last 30 years, just in April and May, tell me all of the precipitation events that were 1 inch of rainfall or more. Maybe I put 5 inches of rain or more, right? I want to know something really extreme, whatever it is. Maybe I don't care about precipitation. Maybe I want to know about temperature or snowfall or any of these other variables that we have available. And I want to know all of the dates, or maybe a count of how many happened, or how many days in a row that happened, right? We give you lots of different options to sort and sift through this vast climate data set to, again, come up with a customized chart that then tells you every single occurrence of greater than 1 inch of precipitation throughout the whole historical record, which in this case, or I only picked 30 years. So this is from 1993 to 2022, but this particular station goes back to 1901. Right? So you can start to get pretty creative in your needs. If something happens in your area that you want to talk about and put into a climatological perspective, there are endless possibilities in this tool. We don't just have individual station records. You can also make maps. And so, for instance, say I wanted to know, this says last month because when I made this, it was January of 2022. And so really this is looking at December of 2021, which I just referenced with how warm, or all of those tornadoes in Kentucky. Now we're going to look at a map of temperature instead. So I want to look at a map, and I say, just for the state of Indiana. I don't need the whole U.S. I don't need the whole Midwest. I just need my state. I can select the networks. Remember, I told you all of these observations come from different types of networks. So you can actually turn on and off the types of networks that are feeding into this map. You can pick your variable. You can decide if you want to look at actual values or how much that value deviates from what we would expect. You create a map, and boy, we can see that December was very, very warm, right? Most of Indiana was falling in this 8 degrees or more above normal for the month of December. This is 2021. I can go back further and I can look at, oh, how is that aggregate together for the whole state, right? I can get a snapshot and say, wow, if we average together or combine all of these individual stations in the state, and these aren't the only ones, those are just major cities, but if we look at all that station data, we can see that for Indiana, it was 8.1 degrees. Well, is that a record? How does that compare? How strange is it to have that much warming, that much warmth in that month? Well, there's another tool for rankings, and when I looked at that, it showed me, in fact, that was the second warmest on record, going back to 1901. So it was a pretty darn big deal. So these are the types of questions that you can ask and answer on a whim in the Climate system. So you can think of 100 different questions. I only showed you a few. Went really fast, but that's just the nature of what we're doing here today. Like I said, I'm going to hand these around, the Climate and the 2-pager, so that you have a reference later when you want to go back and create your free account. And wait, didn't she say that I could find rankings? Yes, you can, and it sort of helps you navigate to that. All right. wrapping up here, I wanted to talk about state climate offices. So we talked about federal data, we talked more about some regional tools. And again, I said state climate offices are going to be your friend in doing the work that you do. So has anybody ever talked to or worked with their state climatologist? Okay, a few. So state climate offices, as we can see here, most states have these. So this map is actually showing us state climate offices that have an ARSCO designation, Association of, I don't know, state climate offices. It's some type of certification from a national program that says your state climate office meets a minimum number of criteria to be a useful, functional data center or information hub. And so when we look at the Midwest, we're doing just fine. Okay, we have a state climatologist. I know all of our state climatologists, so if you have questions on how to get in touch with them, just let me know and I'd be happy to make the introduction. So state climate offices all function uniquely. Some of them are run through universities, some of them are run through state government, some of them have multiple full-time staff. Do we have anybody from Minnesota here? Minnesota has an amazing state-run climate office with 3 full dedicated staff working on just state climate issues all day long, 365 days a year, and they're wonderful people. So compared to Indiana, we have a single person who's not even completely full-time, right? So we do the best we can, but you can see when you have different levels of staffing, you have different levels of output. State climate offices focus a lot on state priorities, right? That's why they're such a resource to you. They're an expert not just in the climate, but how the climate applies to the most pressing issues in your state. They have a much bigger focus on outreach programs, education programs, linking in with climate change, advocacy, and action-oriented groups. And so you will often see them quoted in the newspaper or invited to give presentations or doing a lot more of that on-the-ground engagement that you're not going to see from NOAA. You may or may not see from the regional climate centers, right? These are much more localized folks who have that intimate knowledge. And the one thing that I love is that they also take it upon themselves to start filling some of these climate monitoring data gaps. So yes, another set of networks collecting data. Has anybody ever heard of a mesonet? Mesonet, okay. So mesonets is a mesoscale network of weather stations. So mesoscale is just a spatial scale that is often used in meteorology and climatology to describe something a little bit smaller than this big, huge scale, if that made sense. So think of it like on this map, I have my state and I have all these points, and that's where all of my high quality weather stations that are run by my state might be found. Okay, so these are not federally funded data. These may or may not be publicly available. The types of instrumentation that they use, the installation of them, the quality control of them will differ from network to network, right? So those are some of the cons. However, you are getting data, actual on-the-ground observations that you're not getting from these other weather stations at a much higher density. Remember when I showed you that climate reference network map and there were maybe like 50 sites across the whole US. And you're thinking, what good is that? I need solar radiation at a much higher density in my state. I need moisture much more frequently, right? These are collecting data every 5 minutes, not every hour or every day. Well, what can you do with that? You can do a much different type of localized decision support when you have this dense of a network. This is an example from South Dakota. Do we have anybody from South Dakota? No, South Dakota is wonderful. So if you ever get to interact with the folks from South Dakota, they have this mesonet, and because they have this high density of stations collecting very high quality, like every minute to 5 minutes, they are recording and reporting out data. They have temperature sensors at multiple heights above the ground, not just one temperature. When you measure temperature at different heights, you can understand how that temperature profile is changing. Does anybody here do agricultural work? If you're spraying pesticides And there is what they call an inversion, where the temperature is not cooling with height, but it's warming with height. Think of it like a cap over your air, and anything you spray is just going to drift all over the place. It's going to land on your soybean. It's going to land on your house. It's not going to go on the target you wanted. So how do I know if I'm supposed to spray? Well, this Mesonet takes measurements at boom height, so where that sprayer would be at. They take measurements of the temperature throughout the vertical profile. They make measurements of the humidity, which also affects how things move in the air. Do you see where I'm going with this? You can make highly localized tools that then say, yes, green is good, you can spray, or ooh, I don't know if you should spray. You might want to hold off a few hours, right? So these are the types of things you can do. So maybe it's on flood control. Maybe it's on apples and spraying for pesticides. Maybe it's looking at the amount of wetness and how fungal diseases are spreading in an ecological setting. These are all the types of things that you can do when you have a really dense network of high quality measurements. So I'm a big fan. They're only starting to take off. They can be hard to work with. So again, that's where your regional climate centers come in, is helping you figure out and gain access to all of these incredible tools that are out there. All right, I'm going to hand it over to our friends at Climate Central because they have a little bit more interactivity. So if you're starting to feel bored, you'll feel less bored. But do we have time for a couple?
Yeah, I was just going to say, if anyone has any questions over what Melissa's just say, why don't I, so everyone online can get your question.
I have a very inane question, which is, why doesn't Massachusetts have a state climate office? They were the only one on the map that was white.
I don't know exactly. Sometimes there's history behind that, like there used to be one and then there's not anymore. Sometimes it could be that they have somebody working in that role, but they're not formally recognized. Sometimes it's just they don't have it. Most places do, but not Massachusetts. I'd have to ask our friends in the Northeast what the story is on that one. I'll let you know if I find out.
I don't know. We'll see if this is working.
Maybe they got in a fight with the national organization. My question is, I spent a lot of time on Lake Superior and listening to NOAA, and they're always talking about spotters. So we need spotters today, or no spotters needed. Are they plugging into, are those individuals providing data into one of these networks?
So NOAA does have a lot of different observational databases. When you say spotters, are you thinking like severe weather, or are you thinking of like, I need you to be an observer?
They just say spotters are not required or whatever. So I don't know who they are. That's
Severe weather.
Yeah, so usually spotters are for severe weather. They do hold trainings on getting the public educated and engaged on being those eyes on the ground to actually say, this cloud is rotating, or no, this cloud is not rotating, or you should be taking shelter, things like that. So there are, when it comes to severe weather, the spotters, and they use that information, they collect it in a database, and then the National Weather Service will go out and do storm surveys to identify, was there actually a severe weather event? And if there was, then that goes into a collection, a database. However, I should say, not related to spotters, related to all of these other observational networks, the co-op stations, those are all volunteers, people in the public who have the equipment on their property. They're trained to be these observers. I'm actually the backup snowfall measurement observer for my local co-op station, just new, fresh this year, and we haven't had really any snow. But they rely on all of that. There's a lot of opportunities if you run a nonprofit, or if you work in a school area and you want to get folks involved in weather observations, there are so many opportunities, and that's a great way to get people learning about data science, to learn about what we do with all this data that we then collect. And so that's a little off topic, but hopefully it answered your question. We have
I just wondered, how fine grained can this data collection be? For example, in cities, other cities that are measuring the effects of urban heat islands,
how moisture behaves differently in an urban environment?
Yeah, so there are some networks that are micro scale networks that set up very high density number of instrumentation areas to measure that, to measure just that. How are we, how much warmer is a certain environment? How much does the wind change in this area? It's really important for something called wet bulb globe temperature, which is a different way to measure heat stress, not just that standard heat index. The challenge is we don't have those high resolution data sets typically publicly available. A lot of them are done on individual campaigns. And so the National Heat and Health Institute, I don't remember what their name is, National Integrated Heat Health Institute, they've been funding campaigns in the Midwest and elsewhere over summers to recruit people to do these micro scale measurements for just that. It's only a couple year program. And so we don't have those measurements at that scale over a long period of time, but we use the campaigns that we do have that data for to then feed into sophisticated computer models to then try to simulate that in areas where we don't have those observations. And so those networks are really important. I mean, we struggle to even get funding for the federal observation programs for, getting observations on a broad scale where you don't need as many weather stations. So you can see how exponentially more difficult it would be to get a micro scale. So now we're talking about a city probably needing to fund that because they have some very specific needs of their own. So that's typically why those campaigns are short-lived and they haven't been going on very long.
Thank you. Just kind of building off that question, from a city scale's perspective, you're talking about the funding to pull off like a high density decision-making capacity. I have no idea. Maybe you could just gut check a little bit on what are the type of costs involved in, like, let's say that the holy grail would be being able to measure the heat index of an urban inner city area that is environmental justice, and to be able to intervene in such a way, paint the street white, that would reduce the heat, to measurably be able to show before and after. What kind of technology stack in terms of cost, something like that costs?
So think of it this way too. I've talked about these high quality research grade type networks. There are other sensors, other technologies available that can be deployed for less money. A lot of people have what's called a Davis weather station. Davis is a company. They have a personal weather station. So if you go to WeatherBug, you can tap in. You're like, oh, Melissa was full of poop. I see all these other stations that aren't in her list. Those are different types of stations, right? Those are privately owned weather networks that you see through WeatherBug. That might be sufficient for your application. And so one question when we're looking at the cost comparison to set up one of these Mesonet stations, we're talking on the order of $15,000 to $20,000, not to mention the annual operating cost. However, you can set up a Davis station for maybe $600. And so if we're thinking about how we address something like heat index in an urban setting, or how we look at if an intervention had an impact on the heat island, we might not need research grade sensors for that. So one thing that we've been trying to do at the Midwestern Regional Climate Center is get a project going to compare the Davis personal stations to the more research quality where we have them co-located. We have a lot of places where they're co-located to try to understand, do you still get a reasonable type of measurement, right? Because the cost of using something like that is going to be significantly different than a research grade weather station. So I think there are still some questions on the research side of when is it good enough? When is it good enough to be part of our climate record versus when is it good enough for maybe an immediate application like you were talking about? Does that help answer your question?
Yeah, and how much, just from that, I'll let it go, but how many of those would you need to cover a city?
Not sure. It depends what your question is. Some variables are very continuous, right? Think of temperature. We have temperature everywhere. So, and it's not going to change that much unless like a big front is coming through, or, you know, there's going to be certain areas that we know just from physics are going to be similar. But if you're talking about rainfall and flood vulnerability, we know that it can be raining really hard here and a mile down the street, they're seeing nothing, right? It's not a continuous variable. So some of these questions of the density just depends on the question you're trying to ask. So one more question, then we're going to move on. Oh, we got to move on now. You can talk to me later about your question. All right. Thank you so much. And pass it to Sherry.
Yeah, thanks. So if anyone has a question, you can put it in the app, and I'll be monitoring the chat for questions, and we'll try to get to them at the end before we're done. I'm going to, where am I going to stand? I feel like I'm so short, and I like swallowed up behind here. So I'm going to stand to the side a little bit. So I'm Sherry Bell. I'm with Climate Central. I'm Senior Director of Special Projects. With me is Andy Pershing, and he's our Director of Climate Science. We use Melissa's stuff a lot. And what we do is we take all that data and we take it a next step. We do data analyses, and we translate that into, a lot of times, for lay audiences. And I'm probably not going to really stick to this in the interest of time. But who we are, we're a nonprofit, non-advocacy research and communication organization based out of Princeton. Not Princeton, Missouri, Princeton, New Jersey. But we have folks across the globe, and I'm based in Kansas City. What we do at the core is, we like to say, as you can see on our website, we make science clear, we make climate local. And data underpins everything that we do. So when we make climate local, we do like local analyses of a lot of the material that Melissa just talked about. I'm just going to briefly run through how we do it, because we want to get to your turn, and Andy's going to be really involved in that. But if you go to our website, climatecentral.org, and you click on the work, there you will see, I mean, that's the money section there, and you'll see tools, special topics, and data products. So I encourage you at lunch break maybe to sit down and go through it. But what I'm going to show, I'm just going to do a brief overview. Anyway, we're a group of basically in three bunches: scientists, tech experts, and communicators. Andy is a scientist, and I am definitely not. I work on communication and engagement. But all three of those things are baked into all of our programs and tools. As we said, we localize our data analyses. We do some original research, but a lot of what we do is we synthesize, and we take next cuts of things. Melissa talked about the $1 billion disaster. Well, we take that and then we go, how many days have there been since each $1 billion disaster? Are the number of days decreasing between those? So that's the kind of stuff we do. And we build stuff, write stuff, and report stuff. So here's some of the stuff. We do briefs. We have tools. Andy's going to talk about the Climate Shift Index. It's our latest and greatest, and we're really excited about it. And we also try to visualize what we do. So animations, maps, videos, they're all important. One of our premier programs is Climate Matters. We have one meteorologist in here, right? Are you familiar with Climate Matters? No, we have to get you signed up. So is anyone familiar with Climate Matters? Yay! So it comes out weekly as a newsletter, but it's a program that takes a different topic each week and does kind of a deep dive. It's kind of an explainer. This is an example of power outages. Today we have one coming up on wind power, right?
Solar power. Yep.
Yeah, so wind and solar power. We look at trends in precip. We also do things like, mosquito days. So when you go on the website and search through, tools and Climate Matters, you can plug in your state, and then I don't know if mosquitoes, maybe it's pests or something, and drop down menu, and you'll see like St. Louis. Wow, 10 more mosquito days than 15 years ago. So we do that we do the serious, not so serious, but that's the kind of stuff you can find through Climate Matters. So I encourage you to check it out and subscribe. You can do that on the website, and you can always just shoot me an email. I'm sbell@climatecentral.org, and I'll get you signed up. Those come out every week. Program on sea level rise, maybe not as useful for people in this room, unless you're looking to invest in property on the coast, but it's a really robust program. We do partnership journalism, again, but all the stories we do are based on data sets or research papers. And real-time climate, like Climate Matters, you can sign up for it, and you can get emails whenever there is something going on in your community that has a climate link, whether it's a temperature trend or something with precip or solar or wind power, for example, or weather power, which is what this Climate Matters is about. I'm based in Kansas City, so I get a lot on wind and solar. So it'll be like, Sherry, we noticed it's a really windy day today. Do you know that you could power, however many homes with the amount of wind energy that's there? So here's our next thing. I'm going to turn it over to Andy, and it's on attribution science. So, and again, if you have any questions, just put them in the chat or the question part on the app. So,
All right, thank you. I realize that it's almost noon and I'm very hungry. So what I want to do is talk.
Yeah, we go to 12:30.
I know, but my stomach doesn't know that. So I want to talk very quickly about event attribution, and then we're going to do a little bit of an activity, and we're going to ask for your help with something. So who here has heard about climate change attribution, extreme event attribution? Okay, this is a really growing aspect of science. It used to be, if you were to ask somebody, 10, 15 years ago, was this event, right, a storm, a hurricane, a heat wave, was that related to climate change? The dogma was that, no, you can't do that. You can't actually make that link. There have been really deep advances in the science. This extreme events in the context of climate change is a National Academy study that came out about 10 years ago, was really kind of foundational for pulling a lot of the threads together and saying that, for a lot of weather events, we actually can trace things back to climate change. You can't answer the cause question because any weather event is going to have multiple causes, but you can do things like talk about how much more or less likely climate change made that event, how much more or less severe did climate change make that event. So you can start to make very quantitative statements. So it doesn't answer the cause questions. We're usually going to talk about a change in the likelihood or possibly a change in the magnitude. You're getting some interesting stuff on rainfall. A World Weather Attribution, which is an organization run out of the UK, does really fabulous reports on major climate events around the world, and will come up with an assessment of how much more or less likely did climate change make that event, and start to talk about the impacts of that. But they can't do everything everywhere, right? They have to. It's a very detailed process. It takes them about 2 weeks to maybe a couple of months, depending on the event, to actually get their reports together. But you're starting to see things that really speed up. So this was an article that came out, I think, 2 days after Hurricane Ian made landfall, that talked about the influence of climate change on the rainfall from that storm. So it's a really growing field, and that's what I want to talk about, because that's what we're trying to do. So we're trying to take this machinery, especially some of the techniques that the folks over here have developed, and operationalize them so we can do it every day, everywhere, which is in keeping with Sherry's characterization of our mission about really trying to localize climate change. So this is our map. This is the Climate Shift Index map, and oh, it's not moving on me. Oh, because I had an animation. So what I would love for you to do And before I explain what the Climate Shift Index is, we are in the process of trying to retool our Climate Shift Index website. We've been running this for about a year. We've been getting some feedback. We're trying really hard to kind of pull together some of the threads. And so what I would love is for you to take 5 minutes. I'm giving you permission to go on your devices. It'll work better on your computers, but it will also work on mobile. Go to csi.climatecentral.org. It took us about 2 months to come up with that name, the CSI. And what I would love as you're going through this, just poke around, play with the map, see where you can go from that web page. What I'd love for you to do, and we'll have just kind of a quick report out, is like, what are you seeing? What patterns do you see in terms of where the CSI is high or low? What do you think those colors mean? And then, what other tools are available in this family? So I'll give you about 5 minutes, and then we'll come together.
12:05.
12:05. All right. All right. People want a couple more minutes, or have you had enough of the Climate Shift Index? Everybody's good. Thumbs up. All right. Feel free to keep playing with it. I won't be offended. So just very quickly, and I can do this Phil Donahue style. You remember Phil Donahue?
Hey.
Yeah. Okay. Right? All right. I do. So it's just, yeah. Some people don't. Anyway, we'll just run around. So just very quickly, does somebody want to just like characterize a few places that they saw where CSI was high or low? Any volunteers? Anything stick out? Yeah, in the front.
South Sudan, Kenya, Ethiopia.
All right, South Sudan, Kenya, Ethiopia, right? But big orange blob in Africa. Okay.
Was it high or low there?
Was it high or low?
5, high, more likely.
All right. Okay, so does anybody want to take a stab at describing what the CSI colors mean? This sort of gray, funky gray through orange. Yeah.
It's, whatever the temperature is at that point in time. Is it
if it's really orange, that means that it's a certain times more likely to be that temperature because of climate change. And if it's grayer, it's that many times less likely to be happening because of climate change.
Perfect.
So,
Excellent. You passed. All right. And did anybody get from the CSI map to any of the other tools and products? No, right. It's a tiny little link. Okay. So just very quickly, so what I'm going to do now that you've seen it, I'm going to just do a very quick blast explainer of what the heck it is and how we calculate it. And then I'd love to have a discussion about, this product. And if you have feedback for us on the website on how it's presented, we would love to hear that. And I'll put my email up at the end, or you can log it in the Whova app. So I'm going to start here with a temperature anomaly map. So the red means, and this is a particular, this is July 20 from this summer. Reds and pinks are saying that it's warmer than average against the climate normals, and blue would mean cooler than average. Okay. And so then we add the climate shift index on top of that. So it is not an anomaly, but it uses the anomaly. And what we're saying is how has climate change influenced the temperature at that location? And so that allows us to say that, for example, the conditions in Texas on this particular day were in the 2 to 3 level, right? 2 times more likely, 3 times more likely due to climate change. So you can flip back and forth between those maps. This was one of the tools that I was hoping maybe you would find. This is our US map, which uses the climate divisions to display the conditions in the United States, and where we actually let you look at the temperatures underlying the CSI. So how this works is that we start with the distribution of temperature at a location at a particular time of the year in today's climate. Okay, with about 1.27 degrees C of global warming. So we have temperatures that we expect to get, and then we have extremes on either side. And then we gradually, well, we don't do it gradually, but we remove the signal of climate change, and we rewind back to a climate that has no global warming, so 0 degrees of global warming. Now, note what we're very clearly not saying that this is the climate of 1900. Right? Because that's not what we want to assess. We want to understand what would today's world look like with how we've distributed people across the planet, where we've planted the trees, where we've cut them down, where we're irrigating crops, whatever. We want to look at today's world if we were to just have removed the fact that CO2 causes warming and go back to 0 degrees of warming. It's a very technical process. I'm not going to go into the techniques behind that. You should be able to find it on our website. If you're inclined. And so then from these two distributions, then we start to build up our CSI scale. So 0 is in the middle. It means that there's no change. And so we're in this region where there effectively is no change. The temperatures are equally likely, more or less, in both climates. Then as you move to the right, you get to the warmer climates, and you can see how much more likely it is. And the hard thing is, like, as the values decline, it gets a little harder to see the change, but way out in the tails of the distribution, you get much larger ratios. And we go out to about level 5 times more likely due to climate change. Many of the studies, like you'll hear some of the world weather attribution studies will say, 100 times more likely. They had one, I think the Pacific Northwest event that was like 1,000 times more likely. And once you get out into the tails of the distribution, you have to get very, very careful with the math. We are not able to automate that careful math. So we've automated the simple math, which allows us to stay within this -5 to 5. And so then we have these cool regions that go down to -5 as well. And this is something, as we work a lot with TV meteorologists, and a lot of them are like, why are you giving us this less frequent scale? Why are you giving that side of the map? A lot of people find that very confusing. We felt like it was very important as we were developing this tool to be super transparent, right, with people that, that climate change, that cold conditions still exist. We want to be able to emphasize them, and we want to be able to say something about them. So anyway, here's what our US map tool looks like, showing the actual map of temperature on August 21st. And so then there's the anomaly map. And then you get the CSI color scale, and you can highlight that in Bend, Oregon, it was twice as likely due to climate change. There's another day where it was even more extreme. So these are the products that Sherry talked about. So Climate Matters is our weekly subscription service. All of our products are free. Real-Time Climate will give you email alerts when there's something interesting going on in your location. Interesting ranges from localized alerts about weather or solar. We also do monthly climate summaries for different locations. And we occasionally will do things like help you understand what the Inflation Reduction Act means. Or sometimes there's a major national weather event like a hurricane or like the atmospheric rivers in California that we will send alerts out through our system. And then we have CSI, which gets you to the attribution of daily temperatures. So my email is there, apershing, and Sherry is there as well. And we would love to get any of your feedback. So I'd love to get a few questions and then we'll go back. I know there were people that had questions for Melissa's too, and I think we have a few online. So this is now just our time. So.
Right. Well, mine is a little bit about my question is about the climate shift index. It looks like right now it's just about temperature. Is precipitation something that you're looking for? Because I know that's a big one that we're looking at as it's shifting.
We would dearly love to do precipitation, and we hear it all the time. There's a lot of demand. So as Melissa said, there's these great products out there, these global reanalyses. So we have built our products on that because we get values every day, everywhere. The precipitation in those reanalyses is not very good. And then you couple that with the fact that the statistics of precipitation are really tough. Like you have a zero, right? You don't have negative precipitation, right? It's zero, and then these very long tails. So we think it's possible to do it, but we think it's probably a multi-year research project, and so we're trying to get that started. So if anybody is interested in that, we would love to advise perhaps a PhD student or something who might help us with that.
Thanks. So another CSI question. How do we think about, and I put this in the chat or the question, a 70-degree day in St. Louis in February is marked as equally likely. So is that, I'm sure it has something to do with the historic data in our region.
So great question. So a couple of things are going on. So in this time of year, and we're starting to switch over into some of the spring patterns, the variability is really large. So the CSI is very much a game between the variability in that location and then the trend or our confidence in the warming trend. And we also use some climate models as well. And so if the trend is relatively weak at this location, even if it's an extreme event, it will we basically can't make a confident statement. And so you'll get a lot of equally likelies. With that said, there is currently a bug in the CSI system where it's actually not assessing it all the way to the temperature of 1.27 degrees C of global warming. It's actually only going to about 1.1 degrees. So things are a little muted at the moment. That's going to get switched. We just noticed that. And we're going to be flipping that over next week. So that will boost a little bit of the signal as well.
So this is currently on a daily scale. Is there any way or thoughts of doing it on different time scales? So like a weekly or a monthly or an annual, not just daily?
Excellent question. So my question to you is, what statement do you want? Do you want the average of the CSI over that period, or do you want the CSI to make a statement about the average temperature?
The latter.
The latter, okay.
Yeah.
Thank you. We can do both of these things, and we've been doing it, and we actually designed the metric, the kind of the math behind the CSI so that we can actually scale up and make those statements. So if you were to be doing an average in your head, it would make sense. So that is something we're working on, and we hope to have maybe in another 6 months or a year or so, some additional ways of looking at that data.
Go ahead. I already did this.
You have to exercise before you get lunch.
Yeah.
So this is all about observational data and analysis of observational data. What about forecasting based on this kind of stuff?
Excellent. So did anybody play with the calendar on the CSI? Yeah. How far were you able to go?
It doesn't let me go back. I tried to go to 2021.
Yes. Okay. It doesn't let you go back, but could you go forward? Did anybody try to go forward?
Yes, still.
Today or tomorrow. So right now we're actually building this off of the NOAA Global Forecast System. So we can go ahead 2 days. We actually look ahead 10 days, but we don't release more than 2 days ahead publicly. And to your question, we can go right now. We have about a year of data loaded in. We are going to be probably later this summer going all the way back to 1970. So we'll have a full daily hindcast. All right,
Who funds your work?
Oh, great question. So we get funding from a number of sources, mostly private foundations and private donations. We occasionally will have some government grants in there right now, but it's mostly in kind of the private funding space, yeah.
Thank you. My question is about, it's kind of, okay, so we have the potential to watch ourselves get cooked like a frog, right? With this tool, I'm wondering, what about the efficacy of more or less likely and more or less severe interventions to go coincide with that? Are you thinking about that?
Yeah, that is fantastic. And so we are not, so we're, as you know, Sherry said, we're non-advocacy. So we tend to not get into a little bit of like what you do with it, but we are very interested in supporting people who do that work. So I think our first goal is to help people just understand that climate change is real and that it's affecting them, day to day in the places where they live, and to really help like people touch, feel, smell what climate change is. But that kind of action discussion, we would love to, we'd love it if our work catalyzed that. And so we would love to be able to support organizations that are trying to do that.
And Andy, I would say that the Sea Level Rise program, again, we never advocate for a specific action, but Sea Level Rise, they do show storm surge, sea level rise by emissions. So, and they're sort of like empowering people with choice, like this is the emissions that we're, the path we're on right now. If we cut it to 1.5, this is what we're likely to see. So if that answers your question, we do that.
I have two questions. The first is, how often is this updated? I'll let you answer that one first.
Daily.
Daily. So like right now when I'm looking at the tool, it has today's date. So am I actually looking at the February 22nd, or is this the February 21st? Like, I don't understand what it means if it's that 22nd.
Today's the 22nd.
Today's the 22nd. So what did it say 22nd on the thing?
When does it upload?
Yeah, maybe that's a better question.
Okay,
When is it updated?
I believe right now our ETL runs at just after midnight GMT, so UK time, and so that will appear as yesterday when you translate that into the US date, because we haven't ticked over our calendars. So we're updating it every day using the GFS forecast that comes out at 0 Zulu, 0 GMT.
Okay, so I'm going to take that back. Yeah, because the default, when we go to the tool, it said today's date, February 22nd, and I'm checking it, and it's not yet noon. I know we probably haven't hit our highest temperature of the day, and so that's why I'm like, wait, is this showing me yesterday's or today? And so some clarity on what it's showing would. Well, I assumed it was showing today as the real time, not as a forecast. I had to think about it a little before I even questioned it.
Thank you.
I did have one other question, but I don't want to be a question hog. What validation has been done on this, or is validation possible, or has this work been published or peer reviewed?
Okay, so validation is very hard, right? Because we're validating the statistics. So what we've tried to do is think very carefully about the sources of error and how we characterize that. And that's one of the things that we're going to be rolling out, are some new ways of characterizing the error. The nice thing is that in the US, it's very reliable. It gets to the point about Africa having a very strong signal. In places where the weather variability is very narrow, subtle changes in particular in the forecast or in the, just kind of natural, essentially forecast error can actually magnify into really big CSI changes. And so we're going to be doing some things to mask out those areas. The methods behind the CSI have been through peer reviewed. So that came out last year. So we use a multi-method approach that uses climate models. It uses the observations, or in this case, the reanalyses, and treats the data in a couple of different ways. So we try to get multiple views of it, and then we're presenting an ensemble average. We're going to be having some more papers coming out, so we'll get some additional peer review on a few of the improvements that we're making. All right, so we'll do one more, and then I think maybe we'll shift back to more of a general discussion.
Mine may be more general. I think this might be a question for Sherry.
Yeah.
And it might be what you're asking. So if you go on NOAA's site, which I go on many times a day to look at weather, they present massive amounts of really discouraging, depressing data every day. This is the second highest, blah, blah, blah. So my question really is, how do you not advocate for a particular solution, but also present information in a way that people will come back and not just give up?
Right. Okay. So I love that question. I've been with Climate Central almost from the beginning, 15 years, and I can tell you that we really adhere to this non-advocacy independence, right? And in the beginning, we did not talk about solutions because we felt like that was, you can't do that. But now we talk about them, but we don't say, and you need to do this, and you need to put these solar panels up. But we offer up the different kind of solutions that are being offered, and we also know that in terms of our communication, what shuts people down? If they just look at information and go, oh my God, there's nothing I can do. So we just like to give people menus. We don't tell them what to do. So I think that's right. But that's what we do.
That's great.
Yeah.
Melissa, you have to deal with this too. Yeah. I'd love to hear your thoughts on it, especially like the optimism piece.
Sure. So before I was in the role at the Midwestern Regional Climate Center, I actually worked for the Purdue Climate Change Research Center, overseeing their state-level impacts assessment and doing a lot of community engagement and talking about it. And we too had a very strong sense of, we are not here to tell you what to do, but rather we're here to tell you what the science is saying will happen under these different scenarios, right? And so depending on the group that I'm talking to, it might be more mitigation focused, it might be more adaptation focused, but oftentimes we would pair together with another organization who maybe did focus more on that advocacy or the action orientation. But really our realm, we stayed to, we stayed in that lane of looking at what the data are telling us. But it was perfectly reasonable to say, if we, let's play a what-if scenario. If we stay on the warmest trends, here's what the temperature would look like. If we took these types of actions to mitigate that and it brought us on a different trajectory, here's the difference. What choice are we going to make, right? So posing these questions of, we have actions to take. We have a menu of actions to take. But my particular role is not to tell you what's best for your family, your organization, your community. So we do a lot of partnering to try to help us with that so we can stay true to our mission and our communication style and what does or doesn't erode our credibility while not just ignoring the solution side.
So Sherry, do we have questions coming through the portal?
We do. So let's see, we only have about 5 minutes left. Let's see.
All right, here's one. As a potential buyer of large-scale solar and wind, we found that the assumptions of solar irradiance or wind speed have significant influence on the financial performance of particular projects. Does MRCC or Climate Central have guidance on accurate, conservative weather data that can be used for predicting renewable energy production? in the Midwest?
So I can take a quick stab at that. We're not in kind of the prediction model, but the Climate Matters that came out today was based on our Weather Power tool, which does take forecasted data and then tries to translate that into wind and solar production. We've found that that process is actually fairly good, and we get actually really good agreement with the reported production on a state-by-state basis through this calculation. So there may be a pathway through there, and so I'd be happy to, if you email me, to connect that person with with some of the folks that we worked with. I don't know, Melissa, if you must have to support.
No, so we don't really work in this space, but I do want to make a shameless plug that your organization, the Midwest Climate Collaborative, is trying to set a research agenda. And this is exactly the kind of thing that research can help inform, right? The way I read this is, what data set or model is the most reliable for helping inform my choice on this? That is 100% a research question, right? There are ways to look at these reanalysis and climate model data and to validate how close they do or don't reflect reality. And so this is definitely something that should be put on your research agenda.
Go ahead.
I have a question about the oracles that feed information in. I saw that NOAA was up there earlier. Are there other entities and agencies or labs that you're thinking about feeding in data for different other models that you can apply to different industries, for example?
So I'm going to give a shameless plug for NOAA. We are so lucky to live in the United States for many reasons, but NOAA, for me, is a really, really big one. We have such fantastic weather and climate data, and all of it is free. NOAA just very clearly, a long time ago, made the commitment to deliver the data for free, with the idea that then there would be this ecosystem of companies, some of us free nonprofit, some of us academic, but also for-profit, that would build products on top of that. So NOAA is such a huge, valuable source for us. We use some data from the European Center for Medium Range Weather Forecasts, which is kind of the EU equivalent of NOAA. Some of their products are free, and we use those free products. That's the ERA5 reanalysis behind us. But their forecast, the infamous Euro model, if you're a hurricane fan, the infamous Euro model that was a really excellent model. I think we priced it out at, it would have cost us about $45,000 a year to use that. So free data is great. We are really lucky in the US to have free data. NASA has fantastic products that have very high, NASA has about the highest trust. If you're talking about working with stakeholders out in the community, NASA has very high trust all across the political spectrum. And so that's one of the things that we emphasize when we can.
Okay, and I'll read one more question here. Is there any other questions from the room though? Okay, well, go ahead.
Are you all paying attention to the environmental economic accounting strategy?
This is the kind of the reporting requirements. Is that?
It's a new national strategy to put nature on the nation's balance sheet, and it's basically a interagency working group, so NOAA plus all the other agencies.
That sounds fantastic. I have not heard of it, so thank you.
Okay. I hear stuff all the time about trying to prevent global warming above 1.5C or 2C, but in Columbus, Ohio, for instance, appears to be far upper these marks already. I understand that global warming is an average over the planet, but why is stuff like this happening where we have days that are 8 degrees above average when we're trying to prevent warming that high?
Okay.
That's a climatologist question.
Yeah. So what we're talking about here is a difference in scale, both in our time scale, so if we're looking at a day versus a year, and our spatial scale, so across the landscape, if we're talking about a single place versus the entire state versus the entire globe. So oftentimes climatologists will talk about an annual average temperature for the globe because that is a very stable measurement. It doesn't fluctuate very much year to year, and so it's very clear the trends and changes as we look at that metric over time. We can very clearly see trends or changes, and something like 2, 3, 4 degrees of warming is a huge deal when you're talking about something very stable. When we start coming down to different spatial and temporal scales, so now we're talking about months, weeks, single days, or we're talking about different locations, an entire country, a state, a city, now we're going to be seeing a lot more variability in our natural climate. Looking at the average temperature here in St. Louis day after day, or in Columbus, Ohio, or wherever we are, you're going to see a lot of variability. And it's a little bit harder to tease out from that particular metric which part of it is an upward march in our temperature and which part of it is the natural variability that we see. And so some of what you're talking about in the question online, when we can have days that are 8 or 10 or 15 degrees above that daily average, and that can happen just within our typical climate bounds, or it could be influenced by the overall warming, and that's where the climate shift index is very useful in giving us that perspective.
Okay, one more final question.
So also for that question, a major part of that is that because of the high heat capacity of oceans, you would expect the temperatures to increase on land it ends up being about twice as much as the ocean. So a 1% Celsius increase globally means continents will go up about 2%. And also you have to be careful comparing Fahrenheit and Celsius sometimes in those numbers.
Absolutely.
I think we should use Celsius, but I don't get a lot of support for that.
I'm a big fan of Fahrenheit.
Okay.
So yeah, I think it's probably a lot of stomachs that are going like, eat me. So I just want to say thank you so much, and we really do want to hear from you. We have all of us here, so please reach out. We would love to know. I mean, as CSI is forming, and what we can do to make it better. What kind of not only how it could be more useful to you, and if you are in if you do much communications or engagement, check out Climate Matters. There's so much there, and I think you'll find it useful. So you help subscribing to something.
Last thing, on your way out, please stop at the table, grab the handouts that I had mentioned, and there's some pens and ice cream things. Please eat them.
Thank you.
Right.